A single laboratory result changed the trajectory of the entire investigation. The cause of death was initially listed as drowning, but the medical examiner disagreed upon receiving the toxicology report indicating the presence of water toxins in the deceased system. This unexpected finding prompted a thorough reevaluation of the evidence collected from the scene and the subsequent autopsy. Initial investigations revealed that the body was found floating in an isolated pond known for occasional algal blooms. Further analysis identified a high concentration of microcystin, a potent hepatotoxin produced by certain species of cyanobacteria commonly associated with harmful algal blooms. The medical examiner concluded that while submersion did occur, the ingestion and absorption of these toxins contributed significantly to respiratory distress and organ failure, ultimately leading to death. Chapter: Case background. The incident under examination occurred on June 15th at a recreational lake in suburban Atlanta, Georgia. The initial report was made to local emergency services by a group of hikers who had been walking along the shore when they noticed unusual behavior among several swimmers. These individuals exhibited signs of distress, including erratic movements and apparent disorientation, while treading water or floating near the shoreline. Upon closer inspection, bystanders attempted CPR on one individual but were unsuccessful in resuscitation efforts. This prompted a call to emergency medical technicians who arrived shortly thereafter. The deceased was subsequently transported to the nearest hospital, where they were declared dead upon arrival due to respiratory failure and cardiac arrest. Meanwhile, other swimmers began experiencing similar symptoms, leading to additional calls for help. In response to these events, local authorities initiated an investigation into potential environmental factors contributing to the sudden onset of illness among the affected individuals. Water samples from various points around the lake were collected for analysis at a forensic laboratory where toxicological screening identified several harmful substances not previously known to be present in that body of water. These findings prompted further inquiry into possible sources and mechanisms by which these toxins entered the aquatic environment. Chapter: Initial findings upon arrival at the scene. First responders observed the deceased floating in a semi-prone position approximately 3 meters from the shore of a freshwater lake. The immediate assessment indicated no visible external trauma or defensive wounds suggestive of violent struggle. Skin showed signs of blanching and mottling consistent with cold water immersion. Initial vital sign checks revealed no pulse or spontaneous breathing, necessitating prompt initiation of resuscitative measures. Preliminary medical evaluation suggested the absence of obvious drowning mechanisms such as laryngeal spasm or pulmonary edema. The presence of frothy fluid at the mouth and nose was noted, but did not indicate typical signs of a struggle against submersion. Environmental conditions included calm water surface with no significant waves, cold temperature around 10 degrees Celsius, and clear visibility. These observations led to an initial classification of the manner of death as undetermined, due to the lack of apparent trauma or definitive evidence of natural causes, prompting further toxicological analysis. Chapter: Forensic investigation at the incident location. Investigators collected water samples from the vicinity where the body was discovered for toxicological analysis. Sediment and debris were also gathered to assess potential environmental contamination sources. Notably, personal items such as glasses and a cell phone were recovered near the water's edge, aiding in identifying the deceased. No signs of physical trauma or defensive wounds on the body suggested natural death or accidental drowning. Chain of custody protocols meticulously documented each sample and item from collection through laboratory processing to ensure evidence integrity. A notable absence was any personal protective equipment, such as a life jacket or flotation device, suggesting possible incapacitation prior to entering the water. Unexpectedly, traces of industrial chemicals not typically found in residential areas were identified in preliminary tests on the water samples. The laboratory analysis included comprehensive toxicological screening to identify and quantify waterborne toxins in the deceased's tissues. Specimens analyzed comprised blood, urine, liver, and kidney samples. Enzyme-linked immunosorbent assays, ELISA, were employed for rapid detection of common aquatic pollutants such as cyanobacteria microcystins and paralytic shellfish toxins. Gas chromatography mass spectrometry, GCMS, was utilized to detect organic compounds like pesticides and industrial solvents, with a detection threshold of 0.1 ng/ml. High-performance liquid chromatography, HPLC, identified heavy metals at concentrations above regulatory limits. Histological examination revealed hepatocellular necrosis consistent with toxic liver injury, corroborated by microscopic findings showing lipid peroxidation and cellular vacuolation in hepatic tissue sections. The presence of microcystins was confirmed at a concentration of 150 μg/L in the liver, indicating significant exposure to cyanobacterial toxins commonly found in contaminated water bodies. The examination of water samples collected from the vicinity of the incident revealed the presence of toxins consistent with blue-green algae blooms. Toxicological analysis confirmed that these substances were present in the deceased's bloodstream, indicating exposure and absorption prior to death. Radiocarbon dating techniques applied to fingernail growth patterns suggested a post-mortem interval of approximately 48 hours. The sequence of events was reconstructed by cross-referencing this timeline with witness statements and mobile device activity logs. Analysis confirmed that the deceased entered the water body at around 15:00 on the day preceding discovery, consistent with reported sightings of individuals swimming in that area. This timeline contradicted initial hypotheses suggesting suicide or foul play, instead supporting a scenario of accidental exposure to toxic conditions. The presence and levels of toxins in both environmental samples and biological specimens corroborated each other, establishing high confidence in the determined sequence of events leading up to death. The presence of waterborne toxins within the deceased system provided critical insight into the circumstances surrounding their demise. Analysis revealed elevated levels of cyanobacterial neurotoxins consistent with exposure to contaminated aquatic environments, corroborated by toxicology reports and environmental samples collected from the vicinity where the incident occurred. The concentration and distribution of these toxins, particularly microcystin, were quantitatively assessed using high-performance liquid chromatography coupled with tandem mass spectrometry. These findings indicated a lethal dose, supporting a conclusion that drowning was both a consequence and cause of toxin-induced respiratory distress. While toxicological evidence conclusively linked the deceased to contaminated water, environmental factors necessitate expert interpretation regarding the specific conditions at the time of exposure. Under oath, the forensic toxicologist would articulate these scientific determinations, providing context for legal proceedings. Chapter: Resolution upon comprehensive toxicological analysis of water samples collected at the scene of submersion and chemical examination of pulmonary tissues obtained post-mortem. It was conclusively determined that the deceased's drowning incident involved exposure to a significant concentration of harmful algae blooms, specifically microcystin. Under oath, the forensic toxicologist would articulate these scientific determinations, providing context for legal proceedings. Initial assessments had suggested possible accidental or traumatic drowning without specific causative agents. However, advanced microscopy and chromatography techniques revealed the presence of cyanobacteria toxin markers in both environmental water samples and biological specimens from the respiratory tract of the deceased. This finding altered our understanding from a straightforward drowning event to one with an underlying toxicological component. The identification of these toxins clarified that pulmonary complications noted at autopsy were likely exacerbated by direct inhalation of contaminated water, contributing significantly to the fatal outcome. This resolution underscores the importance of thorough environmental analysis in cases of suspected water-related fatalities. This case underscores the critical role of comprehensive toxicological analysis in drowning investigations, highlighting the necessity for advanced laboratory techniques and interdisciplinary collaboration to accurately determine causation. The presence of waterborne toxins necessitates meticulous scrutiny of environmental factors. The file remains open,